This is Geometry Lesson 3.3. We're going to be talking about perpendicular lines and how to construct them, as well as the shortest distance from a point to a line. So a little review about this picture. Here we have a segment AB. We have a line crossing through it at point M, and we can see that there's a point on this line that's crossing through it, and that distance from that point to point A and B is equidistant, or equal, which would imply that this blue line is a perpendicular bisector. So A to M and M to B would be congruent, and it would come at 90 degrees. Okay, a little review. It says using your compass, how can you find 2 points on the line that are equidistant from point A? So I'll just grab my compass. And remember, your compass, when you open it up, that would be a measurement that you could make that would be equal in different situations. So if I put my compass at point A and I have it make a circle, the circle could cross this line twice. And those 2 points where it crosses would be equidistant, or the same distance away from A in both locations. So I don't have to make the full circle to show you that it does cross at 2 points. So here we have an intersection, and here we have an intersection. And because both of those points were created by using the same radius length, they would be equidistant from point A. So in this one, we're actually going to use that idea of making equidistant points away from this particular point in order to construct a perpendicular. So I'm going to grab my compass, and we want to create a perpendicular line that goes through the given point, perpendicular obviously to the line that's given. And in order to do that, I need some reference points that are equidistant from that given point. So I'm going to place my compass point on the given point, and I'm going to make an arc that hits that line twice. It really does not matter how big it is as long as it hits it twice. And both of these locations where it hits, I'm going to use to create my perpendicular line. Now, if you remember when we did the perpendicular bisector, we only had a segment. And so we're going to imagine that the rest of this line is gone, and that we're only working with this segment here. And because these were equidistant, if I were to create that line down the middle here, that would be a perpendicular bisector to this segment, and it would create a perpendicular. And so that's exactly what we want to do, is we want to create that perpendicular bisector for this segment. So I'm going to place my compass on the end point, and remember, I need it to go more than halfway across this segment. It could even go all the way to that point if you wanted to. It just has to be more than halfway across. Because we already have our reference point up here, we don't have to make the full semicircle, but you certainly can. You do only need to have it come down here, the opposite of the point. If you wanted it to go all the way up, you certainly could. I can show you on this one too. And so you can see it does cross because of the size of my compass. It does cross at that point. It may not if you do the full semicircle there. But now I've created a perpendicular bisector for just that part of the segment. So I'm going to connect those two intersecting points. Draw in my perpendicular mark. And then if we go back to the line, we now have this black line that is perpendicular to the given line, and it does go through that original first point. So you can also do this same idea when the point is on the line. But when the point is on the line, you do need to make that full semicircle so you can make sure it attaches through your point correctly. So I'm going to grab my compass again. And I did write the steps down here in case you're interested in reading through those. But I'm going to place my point, or my compass point, on the given point. And I'm going to make an arc. It has to hit the line twice. Now I can make it any size that I want, as long as it hits that line twice. Okay, now those two intersections are where we're going to place our compass again this time. So I'm just going to emphasize those. Here's one. Here's the other. And I'll place my compass here. Now it says make the compass slightly larger in this case. By doing that, I'll ensure that it's going more than halfway across. Because the compass started on the point on the line, it was measured for only halfway across, and we need it to be more than halfway across. And then I'm going to make my arc marks. Now I personally like to make the full semicircle so that I can see where it's going to cross twice, but you really don't have to, I guess, since you will have that original point to start from to line up your other arc intersections. Alright, so I have the point here and the point here and also that point in the middle, and I'm going to use my straight edge then to connect those two, or those three, I guess. And then I will insert my perpendicular symbol showing that the two lines are perpendicular. Okay, now in reference to the perpendicular, if you can imagine Division Street right outside the school here, and here's North Campus. Three of my children are standing on Division Street, and obviously you can tell which one is closest to the school. Easton, being on the perpendicular from the street to the school, is the closest. And so anytime that you're looking for the shortest distance from a point to a line, it will be by taking the perpendicular to that particular line. Whoops. So this is called the shortest distance conjecture, and it's just basically what I said. The shortest distance from a point to a line is measured along the perpendicular from the point to the line. So obviously Easton is closest to North Campus, where Eliana and Evelyn would have to walk a little bit farther. The altitude is also a perpendicular, and it's based off of a triangle, and it's a perpendicular segment from the vertex of a triangle to the opposite side, or line containing the opposite side. Sometimes the altitude goes outside of the triangle, especially like in an obtuse triangle here. And so it's not necessarily touching the side, but if you were to extend that side out, it would touch it. Since the altitude can be on any of the three vertices, you just have to make sure that you're looking at the opposite side to be perpendicular. And I will show you how to construct an altitude. So for this one, it doesn't particularly say what base we have to work off of. So you get to declare which base unless it states otherwise. So we'll just use this bottom side as the base, and then I want to locate the opposite corner or the vertice from that base, which would be up here at the top. That would be my point, this would be my line. So we're going to do the same steps we did constructing a perpendicular. I'm just going to emphasize this line a little bit so you can see it different from the triangle. Maybe I can make it a little bit skinnier. And then I'll emphasize the point, which is the opposite corner from that side. So we're going to do the same steps that we did to construct a perpendicular that we did before. So I have my point. I need to make sure that my compass is going to be open enough so that it's going to hit the line twice. I don't care about any of the other sides. And if you notice, it didn't actually hit the triangle, but that's why I extended it out so that I had more room to work with. I'm going to open my compass slightly larger just to make sure I'm going more than halfway across. And I'm going to make my arc mark. Now this time I'm going to make only the arc mark and not the semicircle, so you can see how that works. And where those two arcs cross, I'm going to connect with a straight edge through my given point. Whoops. My thing was quite a bit off, so let's try that again. There we go. And if you notice, this orange line that I put in and our red base, those are perpendicular. So my altitude would be from my vertex right down to my base. That would be the altitude of the triangle. It's also called the height of the triangle. Okay, now this one particularly has a particular base that they want us to have. So they want it to be altitude AB to side CD. Now CD is down here, so that would be our base, and we're looking for the vertex A. B is not listed, so that will be where it crosses CD. So again, A is our point, CD is our base or our line that we're trying to match up with, and we want to make sure that we're going to cross CD twice. And you can see that time I missed it. So what I'd have to do is make my compass slightly bigger and try it again. I hit it twice, so on these two intersection points is where I'm going to put my compass next time. I'll make it slightly larger, place it on those intersection points, and make my arcs below. Where they crossed, and my original point A is where I'm going to connect. And I will draw in my altitude perpendicular symbol. So just this red portion would be the altitude. Alright, next is to construct a square so that AB is the diagonal. Now in order for AB to be the diagonal, I would need it to look like this, but more squarish. And when you have a square, which I'm not super good at drawing a perfect square here, the diagonals together, they will make a perpendicular, and they will actually cut each other in half. So what we want to do is we want to have a perpendicular bisector here. So we are going to take our compass and make a perpendicular bisector. So go more than halfway across, make your semicircle. Do the same thing on point A, same size. And I will connect those with a segment. Oops, I should move that over just slightly. Okay, now to get the perfect landing for the square, I know that on that square, this distance out has to be the same going on the up and down direction. So I'm going to start at the middle, at midpoint, and I'm going to measure out to the endpoint B. And then I'm just going to wrap around, and that would give me the other two corners for my square. So that would be here and here. And then I can connect those with my other segments. Let's make this blue. We've got to there, 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 to there. And I have a perfect square with AB as the diagonal. And these will be the problems that we practice for this lesson.